Well, I have learned a valuable lesson today. If you want to keep your notebook dry and not have all of the ink smear, do not put it in the outside pocket of a suitcase that then gets left outside during a lightning thunderstorm. Okay, well, hopefully it'll dry out soon. So today is one of the biggest days in pre-algebra. In fact, it's one of the most fundamental principles and properties we use in algebra, and that is the distributive property. And trust me, you're going to be using this one a lot, so you're going to want to be comfortable. So today we're going to start off. It could be a little bit sticky. This has a tendency to be a harder day for a lot of people, and that's fine. We're going to be doing a lot with it, and we'll continue to work on it throughout the year. So you don't have to get perfect at it just today. You'll have more chances to see and to use and to understand. We're just going to start off with what some of the basic looks of the distributive property are, and then we'll get into using it for some actual problems. So let's go ahead and start off with probably the most common form, and that's if we have some number A, and then we'll have a set of parentheses, and inside those parentheses we'll have two numbers added together. I'm going to continue to just do it in algebraic form, so A times the quantity B plus C. The distributive property simply states that we can change this. Instead of making it a multiplication problem, we could change this into two multiplication problems that we're just doing some addition with. So A times the quantity B plus C is the same thing as A times B plus A times C. And you may be thinking to yourself, whoa, I don't know about that one. I mean, A times quantity B plus C, A times B plus A times C. I'm not sure. I don't really see that. Well, let's go and try plugging in some numbers. I think it makes a lot more sense if we see it using numbers. So I'm just going to pick some out here. Let's do 2 times, we'll do 3 plus 4, make it nice and simple. Okay. And then I'm going to do the same thing over here, but I'm going to use the distributive property. So I'm going to do 2 times 3 plus 2 times 4. Now, on the left-hand side here, I've got 3 plus 4 in the parentheses. That means I need to do them first. So what is 3 plus 4? Well, it's just 7, so we're going to get 2 times 7 on this side. Over here, I've got 2 multiplication problems joined by addition, so I need to do the multiplication problems first. So 2 times 3 is 6, 2 times 4 is 8, and I'm just going to continue to simplify both sides. 2 times 7 equals 14, and 6 plus 8 equals 14. 14 equals 14? Check. We got it. And you can try that with some other numbers as well if you want to go ahead and try to further prove it to yourself. But it works for all numbers. So that's the distributive property. We're just going to be taking some number times a set of parentheses that has addition inside, and we're going to instead get 2 multiplication problems that we're adding together. It can be really helpful, and you'll do it a lot more as we get into working with more variables. Now, it doesn't always look exactly like this. You won't always have A times the quantity B plus C. In fact, the book really likes to trick you, and he'll try to have you do it backwards. They'll do B plus C, and then they'll have that A. Now, this is the exact same problem we just did, but since they moved it to the other side of the parentheses, they think that you're going to get stumped. But you don't need to. It's the exact same problem. You're still just doing A times B and A times C. So this is still just going to equal AB plus AC. Nothing's changed. In fact, if you get too concerned about it, if you really don't like the fact that B plus C is the A is on the right side instead of the left side, all you have to do is you have to switch the order. Now, since it's multiplication, we know we have a property that allows us to switch that. What property allows us to switch the order in which we do multiplication? Well, that would be the commutative property of multiplication. So you could even rewrite this problem as A times the quantity B plus C, and then you wouldn't need to worry about the fact that it's on the wrong side. Just something to think about. Now, this doesn't always have to be an addition problem inside of the parentheses. In fact, oftentimes it will be a subtraction problem. So if I have A times the quantity B minus C, then we can still do the distributive property. We can still do A times B. And notice I always draw my little rainbow, my little arrows going here. It's good to make sure you remember to multiply times each number inside the parentheses. So you might want to do that on your paper as well, just to give yourself some sort of, mental, visual clue that you want to go to both numbers. So not only do you want to go to A times B, but you also want to do A times C. And that's probably the most common mistake, is people will multiply A times B, but they'll forget to multiply A times C, and they'll get the wrong answer. So A times B minus A times C. Okay? They're equivalent. They mean the same thing. And again, your book could try to, throw you off, do B times minus C times A. And again, it equals the same thing, AB minus AC. Let's try some problems. We're going to sort of try to write an equivalent variable expression using the distributive property. So let's try this first. I'm going to do 2 times the quantity x plus 10. I want to write an equivalent variable expression. So all I need to do is I need to apply the distributive property to this expression here. So we're going to do 2 times x, which equals 2x. It's an addition problem, so I'm going to put plus. And then 2 times 10, which equals 20. So 2x plus 20 is the same thing as 2x, or 2 times the quantity x plus 10. How about m plus 3 times a negative 4? And again, since I started on those negative numbers, it can get a little tricky as to what your signs are, so be extra careful that you're paying attention to what numbers you're multiplying. So, I'm just going to go ahead and draw an arrow here. We've got negative 4 times m, or negative 4m, still addition, plus. And then we've got negative 4 times 3. So we get negative 4m plus a negative 12. And we know that we can rewrite that plus a negative as just making it into a subtraction problem, so negative 4m minus 12. This one just a little bit harder. We'll try one of the ones that's probably the most prone to mistakes, shall we say. We've got negative 3 times the quantity 2y minus 6. Okay, notice we still only have 2 terms inside of that parentheses. We've got 2y and we've got 6. So you don't need to do anything special. You're still just doing the distributive property. Don't get distressed by that. That's fine. Negative 3 times 2y. Negative 3 times 2y, we've got negative 3 times 2. So I'm just going to go and rewrite it. Negative 3 times 2y. And then we've got a subtraction sign, so it's going to be a minus problem, subtraction problem. And we've got negative 3 times 6. Negative 3 times 6 is negative 18. And we're going to be able to do some rewriting here because we can simplify this down further. This is an equivalent variable expression, but it's not a simplified equivalent variable expression. We know we always prefer things to be simplified. So, negative 3 times 2y, well, that's negative 3 times 2, it's negative 6y. And then subtracting negative 3 times 6, which is negative 18. And of course, we can rewrite that even further, negative 6y plus 18. And that would be our solution. The place most students will go wrong on this is that you'll look at it and you'll go, negative 3 times 6 is negative 18, so you're going to do negative 6y minus 18. And you'll forget that this is a subtraction problem, so we already have that minus a negative 18. Just comes down to making sure you remember what our rules are with adding and subtract, or with positive and negative integers, and when we're doing addition and subtraction problems with them. So just be careful. Keep an eye out and make sure you're showing all these steps. If you're showing out all these smaller steps, you're a lot less likely to make some sort of mistake and lose a sign. Now, another area of math which is really common and helpful with distributive property is when we start finding the area of different figures. For example, we had a rectangle. And we know that the width of that rectangle is 5 and the length is 3x plus 2. Then we could apply our knowledge of the distributive property. So the area of this triangle, or this rectangle, well, the area of rectangle is just the base times the height, or the length times the width, right? So I'm going to plug in the values I know. I've got 5 times, that's supposed to be an x, 3x plus 2. And then all I need to do is I need to just apply that distributive property. So I've got 5 times 3x. 5 times 3x is 15x plus 5 times 2, which is 10. So I've got 15x plus 10 as my final answer, because I can't simplify that down any farther. You can't combine a x term with a constant, right? We have to keep those separate. Okay, or you could perhaps have a triangle. So for example, we had this triangle, and if I were to tell you, well, let's say the height of that triangle is 12 minus 3y. I'll make this a little bit harder. And the base of that triangle would be 14. Okay, well, the area of a triangle is 1/2 times the base times the height. So the area equals 1/2 14 times 12 minus 3y. Now, instead of automatically applying the distributive property, multiplying that 14 times the 12 and that 14 minus 3y, I'm going to do some quick cleanup here. I've got 1/2 times 14. Well, I can do that really quick, and I'll simplify this problem quite a bit. So what is 1/2 times 14? Well, that's just 7. So I'm going to myself with 7 times the quantity, 12 minus 3y, and that's a little bit easier to look at. 7 times 12, which is, of course, 84. 7 times 12. And then we've got 7 times 3y. And of course, this is subtraction, so I'm going to put my subtraction sign down there. 7 times 3y is 21y. Okay, that was a brief, rather whirlwind introduction to the distributive property. We'll look at this some more in class. So, come ready, look at it carefully, and we're going to learn some really important algebraic properties here. This is going to be a very large section, but we can do it, and it's going to be very helpful in some future problems. So, have a great night, and I will see you tomorrow.